Arrays are very powerful in LabVIEW, and you can create them on the back panel or the front panel. I'm just going to create them on the front panel for right now. So it's under Arrays, Matrix, and Cluster, and what we do is we click on Array and put that right there. An array is a data structure that can hold elements of the same data type. So right now there's nothing in here and you can tell the arrow is broken. But what we can do is we can make an array and we can actually put in our data type. So this could be an array of booleans if we wanted to, and we could just put that in there just like that. So now if we drag this down, we have an array of booleans, and we can actually activate them depending on our needs. For this example, we're going to use some integers. So we just grab the numeric control and put that in there. And we can make this as large as we want. When building an array on the front panel, if you were to click on this is element number 2, and we can use these arrows to go through. So if I was to put in the number 2 there, we can use these arrows to go through the actual elements of the array. Even though this array shows 6 elements, there's actually only 3 that'll show. And one of the things we can do is we can go to the back panel and go to arrays, and we can look up the array size. So if we look at the help here, we put an array in and it gives us a size out. Do note that when anything is bold on the left side, it's mandatory, so we need this connected. And once we connect this, notice we can run it. We don't need the output, but we need the input. So we can right click, go to create an indicator, and see if we run this code, it gives us the size of the array, which is 3. Visually it's 6, but it's actually only 3. And you can obviously tell with these grayed out cells. We had 3, click run, it goes to 4. The same thing can be done with 2-dimensional arrays. So if we right click on the array counter and we go to add a dimension, now we have a 2-dimensional array. And do note that the string broke because we have a 2-dimensional array going in, and I just copied and pasted this little snippet, so this will not convert correctly. Do note the wires do change. So this is a really thin line, this is like a bolded line, and this is 2 thin lines showing a 2-dimensional array. So if we just delete this, now when we run this code, a 1-dimensional array shows up. So if you need the size of a 2-dimensional array, a 1-dimensional array will give the size, and it'll give rows and then columns first. The order will always be row and then column. So for example, if we were to add another dimension and make this a 3-dimensional array, and we run this, in a 3-dimensional array, it'll give you the page count and then the row and then the column. And page count is how many, you could think of it like this is our 2-dimensional array. Now imagine another array the same size right behind it. So it'd be page 0 is this one, and then page 1 would be the one that follows behind this one. Many times this comes in handy with a for loop. So I'll just delete this, and if I put a for loop, see what I can do is I can take my array, which is the size of 4, take the output, put it into the for loop, take my actual array, put it in here, and now I can index off of my array. So if I run this in execution mode, we can look at this numeric up top here. It's 0, 1, 2, it's indexing through all of our array elements. This is where this little node comes in handy quite often, especially with using for loops in indexing the array. You can now add numbers or do whatever math you need to the array, and then actually bundle it back into the array, which I'll cover in a later video. So hope this was helpful, and stay tuned for more.